Objective: to understand the concept of force and the types of forces that exist in nature. Generally, force is associated with the pull or push of a body. If you pull a body, you exert force towards yourself. If you push, you exert force away from yourself. If you dip your feet in a water current, you will feel the force exerted by the current pushing your feet. After using a comb, if you bring it close to tiny pieces of paper, you will see that it attracts the pieces of paper. The comb, in this case, exerts a force on the pieces of paper, pulling them towards it. Force is an interaction between two objects. Whenever we talk about force, we need to keep two things in mind: the source that exerts the force and the object upon which it is exerted. The study of force is called dynamics. Force causes objects to change their motion. As you know, kinematics is the study of motion. Hence, you can consider dynamics as the cause and kinematics as the effect. The SI unit of force is Newton. It is approximately the force required to hold a body of mass 102 grams near the Earth's surface. Various types of forces exist in nature. The fundamental forces in nature can be categorized as gravitational, electromagnetic, strong nuclear, and weak nuclear. Gravitational force. Gravitational force is the attractive force that exists between any two masses. It becomes dominant when the mass of one of the objects involved is large. It plays a major role in the study of motion of astronomical objects. Gravitational force is the reason why planets rotate and revolve around the sun and satellites around the planets. Electromagnetic force. Electromagnetic force exists between any two charges. Charge can be positive or negative. Unlike gravitational force, it can be attractive as well as repulsive. Two unlike charges attract towards each other, while two like charges repel each other. When charges move, such as the case of the current, create magnetic field around them. Most of our modern world devices such as generators, motors, hard disks were made possible by the well-understood principles of electromagnetic force. Strong nuclear force. The nucleus of an atom contains protons and neutrons. It has a volume of around 10 to the power of minus 44 cubic meters. Protons which are in such close proximity within the nucleus should ideally break apart due to electromagnetic repulsion. But the strong nuclear force, which becomes dominant at such very short distances, binds them together and keeps the nucleus intact. Weak nuclear force. Weak nuclear forces gain prominence when subatomic particles like protons, neutrons, and electrons react with each other. For example, these forces can bring about the conversion of a neutron into a proton, which results in the emission of an electron and a particle called antineutrino. Weak nuclear forces are effective within subatomic particles.